For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, Wi-Fi, small cell, and much more. All right, folks, welcome back to HetNet Happenings. We've got a very interesting show for you this week that ties into a lot of the ongoing coverage we produce here at rcrwireless.com. Big part of what we look at is based around LTE-U currently and how it relates to Wi-Fi. LTE-U is operation of LTE in the unlicensed spectrum that's usually reserved for Wi-Fi. And this is an interesting technology that promises to really deliver a lot more capacity and a better quality of experience to the end user. But at the same time, because of its coexistence in that same spectrum as Wi-Fi uses, there's a lot of concerns around interference and interference management. So much so that the FCC is currently even soliciting input from industry stakeholders as to what the future of LTE-U as it relates to Wi-Fi would look like. So we wanted to take a little closer look at LTE-U and some of those attendant issues. I had the opportunity to explore that with Renuka Bhalerao, who is the principal systems architect for software and solutions at Radisys. So let's take a look at this portion of our conversation. All right, Renuka, I know we're here today to talk about LTE-U, but before we get into that, I was hoping you could give us just a high-level overview of the different services and solutions that Radisys offers, and tell us a little bit about your role with the company.
Sure, Sean. So thanks for inviting us today. Radisys is into the communication industry for, I would say, more than 25 years now. We have been providing the infrastructure, the hardware, as well as the software. Now, coming to the business that I am part of, we are into the LTE, 3G, and all of the 3GPP software. We come with a Trillium Software background. What that was back in those days, we used to develop the protocol layer software for all of these telecom network nodes. And bring it now into the current days, what we are doing is an integrated solution that targets the LTE and 3G market, and specifically the small cells. The small cells addressing all of the segments, right from the residential to enterprise to picocells, and obviously our protocol stacks are part of the macro base stations too. And we have been at the forefront. We have been giving our LTE, TDD, as well as FDD solution to various of our customers who get into global carrier space. So we are talking about APAC, we are talking about North America, as well as Europe. And the TDD is what we see as an action in LTE today, more in APAC region. And we are seeing that the North America and Europe is catching up on FDD. And so we are all about the whole integration layer 2 and above for small cells, and for that matter, for the LTE and 3G base stations. We do not only the protocol stacks, the integration also takes care of optimizing and porting that integration onto a given system on chip, the SoCs that come from Intel, Broadcom, Qualcomm, and so on. We port onto them, we optimize the software, we take all of that risk away from our customers of integrating, doing the IoT, doing the application development, SON, O&M, and we take care of all of that with our own efforts, and that gives them a huge time to market benefit. So this is what we are all about, and we are very excited that our solution is now also LTE advanced ready. And that is the next step for the small cells and obviously the LTE industry overall. And from here on, we're looking at the innovations like cloud, the virtualization, or even use of unlicensed spectrum to add more capacity or coverage in data throughput.
Okay, now, and what about specific to LTE-U? What kind of work is Radisys doing?
So LTE-U, or you call it the pre-LAA, it is all about adding more capacity, making use of the unlicensed spectrum. We all know the spectrum currently available in the licensed domain is expensive, is scarce. So everybody is excited about taking a look at the unlicensed spectrum and taking advantage of it to gain more bandwidth, more data throughput. Radisys is not staying behind on that. We are doing two things here. One is to take a look at how the LTE-U or the pre-standard version is shaping up. We know the carriers like Verizon, T-Mobile, they're all supporting it. We know North America is readying for it, not waiting for the standards to get formed up. So we are joining with our SoC partners and coming up with, we call it a proof of concept, where we can test the concept. And it's obviously right up our alley because it's relevant for the small cells. You combine the small cells licensed spectrum with the Wi-Fi related, not exactly Wi-Fi related, but the unlicensed spectrum that is available, which today is being used by Wi-Fi industry. So combine that in a small cell environment, add more capacity for our users. And we are also aware that it has to be with the Wi-Fi users already in that space. So the fair sharing part of it, we are keeping a watch on how to improve on that aspect as well. So to that extent, the second point is that the standards are taking care of it. Release 13 is taking care of the listen before talk version of it. That way it becomes more into the regulatory concept that you can use in all the global environments. So we are obviously watching the specifications and aligning our product towards it. So we're looking at a proof of concept with PLAA coming up towards end of this year. It will be ready as part of our product. And then for next year, we will be obviously going with the standards as we usually do, and we'll be coming up with the LAA version of our product.
Yeah, I'm particularly interested in LTE-U because, as you said, it's not yet standardized, so that's still evolving in that regard. And in the U.S., at least, it's kind of like we might be moving towards some regulatory action with the FCC soliciting comment from industry players. And so I guess to boil that debate down, it seems like proponents look at it as a way to add capacity and give your end user a better network experience. People on the other side of the fence say that there's potential to interfere with Wi-Fi and detract from that. From your perspective, is the interference a problem, or is it something that can pretty easily be managed so that both technologies can share the same spectrum?
Yeah, so as with any new concept, there are challenges. One of them, as you pointed out, it's a spectrum that is already being used, not just by the Wi-Fi industry, but also by other such devices. You talk about Bluetooth and any other consumer electronics. Those unlicensed spectrum bands are being used. So yes, we have to have our play within that boundary, not have to have a major impact for those existing players, but tap into this whole aspect of unlicensed spectrum and take advantage of it. So to that extent, yes, we see that it is something that the whole ecosystem has to solve as a combined problem. And it's not, I won't say it's not feasible to get past it. In fact, the FCC is taking enough of input from the industry and taking enough of action too. We saw that last week, the Evolve came up, and that's more about, again, acknowledging that the FCC is readying for the use of unlicensed spectrum for new innovation. So that's another major step where all of the industry is aligning and getting towards LTE-U becoming part of the HetNet or part of the network itself. So that's good for all of us. And the LTE-U technical challenges are taken care of by not just someone like a software vendor like us, but the handset vendors, the RF part, everything will come together now. And we see that will be the way. Even if the LBT is not a limitation here, I think the North America and Korea will find their way to implement LTE-U, and that will be more of a step to prove the concept as is, and will make a path for the LAA and beyond.
So from your perspective, how do you foresee adoption of LTE-U taking shape, particularly given the fact that there isn't a standard and that the regulatory machinations are a bit in flux? Will people sort of go for it anyway and get something out there that's commercial ready, or do you think that it'll sort of hit a wall and then have to wait on the standards and the regulations to catch up?
Yeah, as we see it today, I believe that it will be taken up for deployment in its current LTE-U form, maybe with some corrections which are already in place by the LTE-U forum. They're trying to make it fair. They're trying to take an action to see that the channels are not overlapping or being used and so on. So in those cases, they are making sure that the Wi-Fi or other unlicensed spectrum users don't have such a major impact. So yes, we think that this will be deployed, but it will also have its own transition path to LAA for sure. So we think that the first half of next year, we will see some deployments in US as well as in Far East, where they're always trying to get ahead on any of the technologies.
And so if just in a hypothetical where Radisys is working with a service provider that wants to deploy LTE-U, what needs to happen on the network and on the software side to facilitate that?
Yeah, so very good question. What needs to happen on the network side? So the network from the base station and beyond remains pretty agnostic. You're not making any changes. You don't have to limit them to any new standard or any new implementation. It's all about the UE or the handset side, the RF and the base stations taking care of it. And to that extent, the prerequisite is very good feature of LTE Advanced, the carrier aggregation. That is what the LTE-U is based on. Essentially, we are aggregating the unlicensed carrier to add more capacity to the licensed carrier spectrum. So to that extent, we have already developed the carrier aggregation feature. It's not only us, I'm seeing it ready for deployment in many places already. So it takes the LTE Advanced feature set into implementation with LTE-U. So that's one of the key requirements that I'm seeing already addressed. And with LTE-U, it will be tested in the live network.
Another thing that we devote a lot of our coverage here at RCR Wireless News to is small cells deployments. This has the promise to add that on-demand coverage and capacity right where networks require it, right at those bottlenecks like hotel lobbies or crowded stadiums, things like that. But there's also a lot of challenges to not only physically deploying small cells, but also managing that from a network perspective. And one of the big things that's emerging in that space is SONE, self-optimizing network technology. So you add all of these layers of complexity with small cells interacting with base stations and other types of access technologies, and you create a lot of management challenges. So in order to dynamically allocate resources and manage the different types of network traffic and the way that they relate to one another, at some point you need to add a level of automation here, and that's what self-optimizing networks enable. So in this next portion of the conversation, we're going to hear from Renuka about some of the ways that self-optimizing networks can really support some of these large-scale small cell deployments that we cover so much. Let's take a look at that.
That's a very interesting topic. Small cells and self-optimizing networks. Obviously, the small cells are touted as adding capacity and coverage. And to do that, you're adding into the HetNet scenario volume of base stations, and which are smaller in size and but larger in volume considerably compared to the macro base station. And there are other aspects of how dense the network will become with addition of small cells. How will the interference matter in such scenarios? So that's where SON plays a key role. When we talk about SON, we take it to two different, I would say, tiers of it. One is to handle the whole interference mitigation part of it, and then the other is to provide the complete automation that will be needed for HetNets going forward. So the first part about interference mitigation, a lot of algorithm research that is going on. We have already been part of it in many cases. Our customers have indoor deployments where it's a densification that is happening in somewhere for example, in Europe. And on the other hand, we also have customers who are developing picocells or the outdoor base stations, which fall into the small cell category. Both of them have this interference either with the small cells themselves or the base stations interfering with the macro base stations. And so the EICIC and other ways of overcoming interference, that is what we have been working on for last almost 2 years, I would say, and have been bringing those algorithms for our customers. Now, talk about the other aspect of SON that goes into 3 phases. First one being the automation of the plug and play part of it. How do you not have manual effort spent to bring in those number of small cells into the network? So the self configuration plug and play software upgrades done remotely, that's the first phase of the SON functionality, and that is taken as a key or a mandatory requirement everywhere we see the deployments today. And then from there on, you go into the second phase where you come to the actual SON definition of how do you now optimize the network using the SON functionality. So that is all about input output, meaning the small cells go and provide the live data about what is going on and what they see in their neighboring environment. And that gets fed into a major SON algorithm to then come up with decisions about how do you configure the network, how do you change the settings on each of those small cells and so on. So that's the optimization area, the second phase of it. And we are already seeing extensive work going on into that, the mobility related optimization, the failure scenarios, and how do you come out of that, and capacity addition and deletion, and all that going on while you take care of energy saving and other such things along with it. And then the third phase of SON, I call it a slightly distant phase, but yes, necessary, the healing of the network. So takes the optimization part of it to the next level. You're talking about coming out of failure and managing the live network with a mix of different types of access points, base stations, and have a centralized vision of the whole network, and then come up with solutions to keep it alive, keep it efficient. So that's the third phase of it. I would say that is still part of the standards, and so not so much into deployment unless it is needed in a specific scenario. So SON, yes, it's a topic in itself, but I think that's a summary. I would say we in our solution today have the self configuration and optimization part already available, and have been helping certain deployments from that point of view.
Yeah, I guess what strikes me about SON is that all of the big service providers are racing to add metro density ahead of a 5G standard, but they're a little slower on adoption of the self-optimization. And it seems to me that it's not going to be something that it'd be nice to have. It's going to be absolutely imperative to manage these networks that are right around the corner.
I'm with you on that. So the operators are today seeing only the first part of it, because all they're caring about is to get the network up and running. And that's why the self-config and the plug and play is getting that much of importance. But we're not very far from seeing those real challenges of interference, of optimizing the scenarios of handoffs and so on. So yes, in fact, we do have customers in that phase of their deployment already and have been asking for complex features. And that itself tells us that once it all goes into those many volumes, all of this is going to be mandatory. The self-optimization is going to be a mandatory or a key feature that is not just nice to have, like you mentioned.
Right. Well, Renuka, I really appreciate you taking some time to talk with me. That's all the questions I had prepared. If there's anything else that you'd like to tell us about that Radisys is working on, by all means.
Oh, thanks, Sean. Yeah, nice to chat about the LTE-U topic with you. At Radisys, as mentioned, we are excited about getting our LTE Advanced Ready solution into deployments. We have been working hard for last few years on integrated small cells. When we started back then, it was a new concept, new product. There were not many practical challenges being seen. But today we are at a step where we have customers who have gone through rigorous trials and have been shipping products. So nice phase for a product development part of it. And we are looking forward to LTE-U, or for that matter, the other advancements all the way up to 5G to bring into our product.
Well, I want to thank Renuka for keeping us up to date on all the work that Radisys is doing around LTE-U, Wi-Fi interoperability, as well as self-optimizing networks and small cells. For a lot more news and information on these topics and many others, I'd encourage you to visit us at rcrwireless.com and subscribe to our daily news blast to get those headlines delivered straight to your inbox. For previous episodes of HetNet Happenings and other RCR TV productions, I'd encourage you to check out the RCR TV website as well as our RCR Wireless News YouTube channel. I'm Sean Kinney, and thanks for tuning in to HetNet Happenings.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com, on Twitter at Sean Kinney RCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.